Okay, so hello everyone. Today we are going to solve two questions of the dynamic programming playlist out of 215 problems. Okay, so the first problem named as climbing stairs, we are going to solve it. Let's read the problem statement first. Okay, so you are climbing a staircase. It takes n steps to reach the top. Okay, so each time you can either climb one or two steps. In how many distinct ways you can climb to the top? Okay, so let me explain the problem statement. Mm, yes, from one point we can jump to the uh, from one point we can jump to the either one point ahead or either 2 point ahead. Okay, so we have to count the number of ways to reach the nth stair. Yes, that's the problem statement saying. Okay, so how can we solve it? So in order to solve the problem statement, first we define the dp states. uh, in this problem, dp of I represents the number of ways to reach the ith index. Okay, so now dp of 0 means number of ways to reach the zeroth index, that is equal to 1, and dp of 1 means number of ways to reach the 1 index, that is also equal to 1. Okay, so now comes the main part. uh, Transition. dp of I, we can reach ith index from dp of I minus 1 plus dp of I minus 2. uh, dp of I minus 1 means from this index. dp of I minus 2 means from this index. Number of ways to reach this index from this and from this. So now here comes the final answer. Final answer, final answer stored in dp of n, because we have to find the ways to reach nth index. Now comes to the coding part. We will define the dp vector with initializing 0, and dp of 0 is equals to 1. Number of ways to reach 0th index. Number of ways to reach 1 index is also equal to 1. I will run a loop from 2 to n, and I will this is my transition state from previous index and from other previous index. Now the final answer is dp of n, and yes, that's it. That's the whole crux of this problem. Okay, so now we are going to solve the second problem of this video. The problem name is best time to buy and sell stock. Okay, let me read the problem statement. You are given an array prices where prices of I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choose a different day in the future to sell that stock. Okay. Return maximum profit you can achieve from this transaction. If you cannot achieve that profit, return 0. Okay. So the problem states that if we buy an stock from the ith index, like I can buy stock on second day with the price of 1, and I can sell that stock into another day in a future, like I can sell on third index, I can sell on fourth and fifth and sixth with the price of sixth, with the price of this array. Now the profit I will get from it, uh, the absolute difference between them. Like if I buy the stock on second index, the price of the stock is 1, and I sell it on the sixth index, the price will get 4. So the maximum profit I will get 4 minus 1 is equals to 3. So I have to maximize this profit. Okay, so now the problem statement is clear to everyone. Okay, so in order to solve the problem statement, uh, let's suppose that if I'm standing on second index and the second index price would be 1, and if I already knew what would be the maximum price I can sell on future days from I plus 1 to n, for the maximum price 6 on fifth index, then I can subtract 6 minus 1 is equals to 5. 5 would be my maximum possible answer for the ith index. So now to implement this strategy in big of n, we can use the suffix array uh, to store the maximum up till n minus 1 to ith index from back n plus 1 to the ith index. Okay, so let me show the coding part. First, we will create the suffix array. Initializing with 0, we will initialize vector size. Okay, so from back for the last index, suffix of n minus 1 is equals to v of n minus 1. So we have to run the loop from n minus 2, and suffix of I, maximum of suffix of I plus 1 and v of I. So now we have to store the answer. We will declare the answer variable which can store the maximum value. Now we run the loop from till n, and we can find suffix of I plus 1 minus k v of I. We will run n minus 1, and answer is stored in answer max of answer comma l. Yes, that's it. Let's run this. Okay, 24 suffix of suffix of I plus 1 minus k v of I. I. Okay, so it's my fault. I minus minus. Let's run this. Okay, so it's accepted. Let's submit this code. Okay, accepted. Thank you very much, guys.